And hi everyone. In previous video we discussed about the problems on convex lens. So that's a very important problem. Up to now you didn't saw that one, just go ahead and watch it once. So children, in this video I am going to explain one more important problem that should be based on the topic of lensmaker formula. Lensmaker formula it is there, and that one problem will be there. So in public examinations there must be one problem in 4 marks questions. Either it is that should be on concave mirror or convex lens or convex or concave, anything on lenses one problem will be there, on mirrors one problem will be there. So in those two one should be taken as choice. So like that's why this is a very important problem, this one, and previous one also very important. So children, up to now you didn't watch my videos, just go and watch all the videos and subscribe my channel. After watching the video, like and share, comment the video. Now I am going to the problem. Here one problem is waiting for us on board. Let us see. A double convex lens has two surfaces of equal radii r and refractive index n is equals to 1.5. Find the focal length f. A double convex lens, biconvex lens, has two surfaces of equal radii of r and refractive index is how much? N is equals to 1.5. Find the focal length f. So here we know that this is a biconvex lens. This is a biconvex lens. Clear children? So here I am showing that now this is the first surface, first refracted surface. This is what? First refracted surface. So for that I am drawing here, this is the one sphere. Now this is the center. Here we are taking the C1. Clear? Now this point to this point C1 is what? Nothing but R1. Clear? So this belongs to first refracted surface. Now here this is the second refracted surface. This one is first refracted surface and this one is the second refracted surface. Clear? So this is the sphere for second refracted surface. Clear children? So now this is the C2. What do you say, center? This is C2. And now from optic center, this is the optic center. Optic center to C2 it is what? R2. Clear? So simply I am showing like this. This is the biconvex lens and this is the C1 and this is C2. Clear? Same thing I draw here. This is C1 and this is C2. Here this is now C1. Optic center to the center of curvature, what we call? Radius of curvature. Radius of curvature. And this is optic center to the C2, second radius of curvature, R2. So in that problem, what he was given, has a double convex lens has two surfaces of equal radii. That means R1 is equals to R and R2 is equals to R. He was given R1 is equals to R and R2 is equals to R. So and refracted index is N is equals to 1.5. Find the focal length f. So here children, the incident ray is moving in this direction. The incident ray is moving in this direction. So children, according to sign convention, the distances what we measured, the distances what we measured in the direction of moving of light, those should be taken as the positive. The readings what we are taken in the opposite direction of incident light rays, those should be taken as negative. Clear? The distances, the measurements what we are taken in opposite direction of the incident ray, they should be taken as negative, and the measurements what are taken in the direction of incident light is positive. That's why here in this case the light is coming in this direction. That's why here light is moving like this. So that means R1 is positive here, R2 is negative. Clear? R1 is positive and R2 is negative, and this is the R1, this is R2. Here R1 is positive, R2 is negative. Got children? So here clear children? So R1 is positive, R2 is negative. Just see here now. I hope you understand. So now I'm writing given values. So what he was given? R1 and R2 both are equal. That's why I'm taking let R1 is equals to R2 is equals to R. Clear? After that, what he was given? Refractive index is how much? N is equals to 1.5. Now what you have to find? Focal length we have to find. We want to find out the focal length. We need some F value. For that, we know that lensmaker formula, children, this lensmaker formula is important for 1 mark also. For 1 mark and 2 marks also, the question will be asked like this: what is lensmaker formula, and explain the terms in that equation. So here, this is the formula here. 1 by F is equals to N minus 1 into 1 by R1 minus 1 by R2. This is the formula. This is called lensmaker formula. Clear children? 1 by F is equals to N minus 1 into 1 by R1 minus 1 by R2. So here what you have to say? 1 by F is equals to N minus 1 into 1 by R1 minus 1 by R2. Here what is F? Focal length. And what is N? Refractive index. What is R1? Radius of curvature of first refracted surface. And what is R2? Radius of curvature of second refracted surface. Children, 1 by F is equals, don't forget, 1 by F is equals to 1 by V plus 1 by U, what we call mirror. This is what? Mirror equation. And 1 by F is equals to 1 by V minus 1 by U, what we call lens formula. Clear? And now this is the lensmaker formula. Don't confuse. 1 by F is equals to 1 by V plus 1 by U, that is the mirror equation. And 1 by F is equals to 1 by V minus 1 by U, that is the lens formula. And now this is the lensmaker formula. 1 by F is equals to N minus 1 into 1 by R1 minus 1 by R2. Clear children? Now in this case what I am telling, F is focal length and N is what? Refractive index, and R1 is what? Radius of curvature, and R2 is what? Radius of curvature. So substitute all the values. 1 by F is equals to, what is the N value here? 1.5. 1.5 minus 1 into 1 by R1. R1 value is what? R. And minus of 1 by R2. R2 is what? Minus. Clear? So here R1 is equals to plus R and R2 is equals to minus R. So here what do you get? 1 by F is equals to 1.5 minus 1 means what? 0.5. 0.5 plus, what do you get? 1 by R plus of minus plus 1 by R. So then 1 by F is equals to 0.5 into 2 by R. 1 plus 1, 2, what do you get? 0.5 into 2 means what? Nothing but 1. So 1 by F is equals to, what do we write? 1 by R. 0.5 into 2. Then what do you get? 1. Then 1 by F is equals to 1 by R. That means 1 by F is equals to 1 by R. Then F is equals to what? R. So nothing but, for this situation, this is the solution, and F is equals to R. Nothing but radius of curve equals to focal length. Clear children? See once clear here. A double convex lens has two surfaces of equal radii. So that's why here what you take in, R1 is equals to R2 is equals to R. I already told you how we can take R1 is positive and how we can take R2 is negative. I explained just now. That's why here R1 is equals to positive R and R2 is equals to minus R. According to sign convention, we can take that. And now next thing is what? Given the value is N is equals to 1.5. What is N? Refractive index. and f is equals to, we have to measure, that is the focal length we have to calculate. So for that, what we are using, lensmaker formula. 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. Here f is the focal length, n is the refractive index, r1 is the radius of curvature of first refracted surface, and r2 is the radius of curvature of second refracted surface. Now we are substituting values. N is 1.5, r1 is equals to r, and r2 is equals to minus r. Then what do you get? 1 by f is equals to 0.5 into 1 by r plus 1 by r. Then 1 by f is equals to 0.5 into 2 by r. That means 1 by f is equals to 1 by r. From that, what do you get? F is equals to r. So this is the solution for this problem. This is the one of the most important problem. So you can note the answer in a book after watching this video. So I hope you understand, children. We will meet in the next video with another topic. Bye. Take care.